Hi, this is Rafikul, and today my topic is abstract algebra, and I will complete today a huge topic. Like, let me start with the set. Set is what? A collection of objects or elements. It should be well defined. For example, you see that A is a set of collection of natural numbers. Those are greater than 3. So we can easily collect all the elements. Similarly, for B, those numbers are from R which are lying between 1 and 2. So it's all set. You see that C is collection of students which are tall in a class. So you can't define that up to which height we are taking that student is tall. So it is not a well defined thing. So C will not become inside. And for D, C the collection of students whose percentage in an exam is greater than equal to 60. So it's also you might think that the since percentage is mentioned, so we can take the students easily, but class is not mentioned there, so it is not possible to take those students. And then next topic is relation. Relation from A to B is a subset of A cross B, and relation from B to A is a subset of B cross A. You see that in A, 3 elements are there, and B, 2 elements are there. So A cross B, how many elements are there? 6. So we are taking the elements for PA and first element A, first element B, then we are taking and putting in a pair. So it's a element become and that element, new element becoming a set of A cross B. Okay, so a relation is a subset of A cross B. From A to B is subset of A cross B, and from B to A is subset of B cross A. Cardinality of a what? The number of elements in a set is called cardinality. Suppose in a set A, the number of elements are there. M number of elements there, and in set B, n number of elements are there. Then how many elements will be there in A cross B? Mn number of elements will be there. So yeah, that's it. Next is type of relations. Like there are different type of relations, but first let me introduce you with the replaceable relation is what. Let R is a set, R is subset of A cross B. A set like A cross B is what? A cross B is a relation from A to A. Okay, so earlier I told you that A cross B is a relation from A to B, but here A cross A, so A cross A is a relation from A to A. So unless R is a subset of A and A cross A, we call that R is reflexive if for all A belongs to A, comma A belongs to R. Okay, if that condition is satisfied, then we will call that relation is reflexive. Otherwise, not. So taking that A is a set of natural number and relation defining the we are defining the relation R so that A related to B if A divides B. So you see that that 1 comma 1, 2 comma 2, all 3 comma 3 all belongs to that relation. Why? Because of 1 divides 1, 2 divides 2, 3 divides 3. So you see that for all A 1, 2, 3, 4 belongs to A, 1 comma 1, 2 comma 2 belongs to R. So that relation is reflexive. And next, if take same A is natural set of natural number, and here the relation I am defining it as GCD of A comma B, A equal to B, if and only GCD of A comma B equal to 1. So you see that 1 comma 1 belongs to that R. It is obvious, okay? Because GCD of 1 comma 1 equal to 1, but 2 comma 2, 3 comma 3, this all are not belongs to R because of you see that GCD of 2 comma 2 equal to 2, not equal to 1. So parallel parallel 1, 2, 3, 4 belongs to A. 1 comma 1, 2 comma 1 comma 1 belongs to, but 2 comma 2, 3 comma 3, these things are not belongs to that set. So it's not a reflexive relation. Okay. Next is irreflexive relation is what? For A comma for A belongs to A comma A should not belongs to R, then we call that relation is a and irreflexive relation. Let me give you some example. Here I am taking a set of 3 members 1, 2, 3, and I am defining relations on A R1 1 comma taking by taking 2 elements 1 comma 2 and 1 comma 1. You see that 1 comma 1 belongs to 1 comma 1 belongs to R1. But for irreflexive relation, we know that for all A belongs to A comma A should not belongs to that relation. Then only we can say that that relation is irreflexive relation. But here, since 1 comma 1 belongs to that R1, this relation R1 is not irreflexive, Okay. Also, it is not a reflexive also because 2 comma 2 for reflexive for all A belongs to A comma A belongs to R1. Should belongs to must belongs to R1, but 2 comma 2, 3 comma 3 are not in R1. So neither R1 is a reflexive relation nor it is an irreflexive relation. Okay, you see R2 For all A belongs to A, A comma A does not belongs to neither 1 comma 1, 2 comma 2, 3 comma 3. It is not in R2, so it's an irreplaceable lesson. In case of R3, you see 2 comma 2 belongs to R3, so it's not an irreplaceable lesson. And next is symmetric lesson. Symmetric relation is what? R is subset of A cross B. R is called symmetric relation if for all A comma B belongs to R. This is should imply that B comma A must belong to R. Set of human being. Let I am taking a set. That set of human being. Set of human being. I am taking a set that set of human being. I am defining a relation such that A related to B if A is a brother of B. Now tell me, this relation is symmetric or not? No, it's not symmetric because if I am a brother of someone, then it's not implied that someone that fellow or that person is a brother of me or mine. Because she can be my sister or she can be my brother, but there is a possibility that she can be my sister. So it will not become a symmetry relation. In mathematically, that if take A is equal to three elements or A, B, C, and R equal to define a relation A, B, B, C, C, A. For AB, there is no VA, so it's not any not asymmetric. In the second relation, AB is there, so BA is also there in R2, so it's R2 is a symmetric relation. In case of R3, AC is there, but CA is not there, so it is not a symmetric relation. Asymmetric relation is what? Next asymmetric relation. For all A comma B belongs to R, B comma A should not belongs to R, then we will call that this relation is a asymmetric relation. In case of the previous, later I am taking this previous example that you see A comma B belongs to R1, B comma A does not belongs to B comma C belongs to C comma B does not belongs to C comma. So the R1 is a asymmetric relation, but R2 is not a asymmetric relation because it is a symmetry. If some relation is symmetry, it can't be a symmetric relation. In case of R3, AC belongs to, so R1, R3, but CA does not belongs to. So this is also you can say verify that R3 is also a asymmetric relation. Okay, and next is antisymmetric relation. Antisymmetric relation is what? Let R is a subset of A cross B, and R is called antisymmetric relation if A comma B belongs to R1 and B comma A belongs to R1. Together imply that A equal to B. For example, let here A equal to 1 to 3, R1 equal to, and defining the relation R1 equal to 1 comma 2 2 comma 1. Is it antisymmetric? No. Why? Because 1 comma 2 2 comma or it's belong to the R1. It is okay, but 1 dot is not equal to 2. Okay, so that's why R1 is not a symmetric relation. Next R2 1 comma 3 and 2 comma 3. Yeah, 1 comma 3 and 3 comma 2 belongs to R2. It is okay, but 1 does not equal to 3. So this is also not antisymmetric relation. In case of R3, that 1 comma 1 and 1 comma 1 belongs to R. So R3, so 1 and 1 equal to 1. So this one is equal to R3. R3 is antisymmetric. You can say that 1 comma 1 belongs to R, and again you are taking 1 comma 1 where you from where you got 2 times. I am taking that same element 2 times. You can take the same element also, okay? That 1 comma 1 and again 1 comma 1. For R4, this is also a antisymmetric relation. Okay, so let me give you an interesting example. That say A is a set of human being and defining a relation R such that A related to B if A is a brother of B. Now tell me, this relation is antisymmetric or not? It's not antisymmetric. Why? Because A is a brother of B. Okay. B is a brother of B. Okay. I am brother of my brother, and my brother is brother of me, but we both are different person. Okay. So this is not an antisymmetric relation. Next, transitive relation is what? A relation. Okay, a relation is transitive relation. For all A belongs to unless is transitive for A comma B, B comma C belongs to R. This together imply A comma C belongs to R. Okay, let me give you an example. Then only you can understand. Taking A is a set of integers. Okay, integer in the sense what like my plus 0 plus minus 1 plus minus 2 and so on, and taking our subset of a cross A, and when defining relation, and how I'm defining that relation, the A related to B if and only if 3 divides A minus B, that is A minus 3 divides A minus B. And if you will calculate that, you can find out that if 3 divides A minus B and 3 divides also B minus C, then 3 will divide C minus C. Because we can add those terms, okay? So A minus B plus B minus C, and cancel out B will be cancelled out from that plus minus, and you can easily verify that A will, sorry, 3 will divide C minus C, that is A comma C. This implies that A comma C will belong to that set R, and correspondingly R will become a transitive relation. Equivalence relation is what? A relation will call as equivalence relation if it is satisfy three property